whatever. So baby example. You have a triangle. Two. Find all values of trigonometric functions. It means what? Find the value of cosine, sine, tangent, cotangent, cosecant, secant. Yes? Go. So first example. What do you need to do first to answer for that?
We know sine theta is 2/3.
Yeah, that's only I know. Do you know cosine? Directly only you can get what? A sine value and cosecant value, right?
Right.
But the other one, how do you figure out another four?
Pythagorean theorem.
Pythagorean theorem, that's right. What is it in this example? Oh, let's see, because we need this one, right? Let's say this is x, and let's say y. Okay, what is the Pythagorean theorem?
X
squared.
equals square root of 3 squared.
X
plus-
squared
X squared plus 2 squared equals 3
plus
squared.
2 squared equal to 3 squared, right? Okay, x squared equal to 9 minus 4 is 5. Here in this situation, we only take care about the what? All the lengths are positive, right? So what is x? Yeah, square root 5. Yeah. Same thing. By Pythagorean, set up what? 5 squared equal to x squared plus 3 squared. Am I right? So x squared equal to 25 minus 9 is 16. So what is x? Yeah. This one, Pythagorean. And 4 squared equal to 3 squared plus y squared, right? So y squared equal to 16 minus 9. It is 7. So y equal to what? Y equal to? Okay, square root 7. Yep, so we prepare everything based on this. So because we know this is square root 5. This one is 4. This one is square root 7. Now we can answer for everything. So, therefore, now sine theta, cosine theta, tangent theta, what is it?
Sine theta
Over
is
3.
2/3.
And then what is cosecant theta?
3/2.
Yeah. Cosine? So secant is
3/5.
tangent?
So 2/5.
So what is cotangent?
5/2.
That's it. Everything same. I don't want to go because you already know that, isn't it? Nothing hard. So yeah, you can handle this. Now, do you remember I assigned the homework because this one? so you already, if you really seriously study that, and then you don't need to worry about any table related with what page 483. So
Wait, which homework? The
you
one that
saw
one.
me too.
Okay.
Yes. Okay, now I told you everything is a review. So now let's go. Page 485. 485. Example 4. You have a triangle. And this is 12, this is 30 degree. And you don't know other part. And this A, H is ABC being called. Solve triangle ABC. What they mean that? It means you have to find the 3 angles, 3 sides. Yes? Understand? So what we needed to figure out? Set, this is X, this is Y. Yes? Am I right? And this angle, B. Yes, we have to figure out, right? So, what is angle A? It's already given. Angle C is already given. What? Yeah? And then what is angle B?
60.
Yes, 60. So we fill up everything, right? Yes. Now, and then what? Your AB is already, we know, 12. Yes? What is your AC? What is your BC?
Right.
How do you find it?
Side right. No.
What do you need? Hint. From the beginning, we talk about the ratio, right?
Correct.
So how do you handle? Why we can use the ratio? Because this angle is what? Special angle. Yes? So,
Sine 30.
for this, what do you need to do? Yes, sine 30 equal to what?
Y over 12.
Very good. And then what is sine 30?
Oh, it's 1/2.
Good. So you have to solve this for y. Yes? Am I right? Cross multiplication. So what is it? 2y equal to 12. So y equal to what? 6. Isn't it? Is it good? Yeah. Because 30 is the special angle. Yes? How about so we solve y. How about x? For x, what do we need to do?
We use the cosine.
Very good. Cosine 30 is equal to what?
√3 over 2.
Eh?
Cosine.
What? Cosine 30 is what?
Cosine 30. So,
Yeah, x over 12. Yes.
yeah. yeah.
What is cosine 30?
√3 over 2.
Yeah. No. What is cosine 30? I'm sorry. Yeah, sorry. Okay, yes, √3 over 2. Am I right? And then cross multiplication. So what is it? 2x equal to 12 square root of 3. Am I right? So x equal to what? 6 square root of 3. Yes? Do you understand? So we're done. This is a very important technique. Yep. Very important technique. Yes? Good. Why this is available? Because I told you, because this is the special angles. Yes? So you know the value of that. Good.
I have a question.
Yes.
So cosine 30, it according to the circle, it's square root of 3 over 2, but in this case, it's x over 12. Is that? I'm kind of confused.
Cosine is that. Cosine is what? This.
Right.
Yeah, so x over 12.
I know, but why does it say both? It says
Cross
square root of.
multiplication. Cross. This one multiply this.
Oh,
this
that
one.
multiple. Okay.
Okay? So, very important. Now, yeah, we will gonna discuss about some terminology. Page 485. Is a ground, and here is a building. Somebody stand here, and very dark, but only this part has a what? Light. Yep. And this is a horizontal view, because I here. And then me, until here, this angle is what? Angle of elevation, yes? Angle of elevation. One child is crying here. Sit down and, I'm sorry.
She's crying.
Very bad picture, I know. Very bad picture. And crying. And then, watch this. It is what? Angle of depression, yes?
Oh God, that's so funny.
So this is the situation, yeah?
Did you get that from the textbook?
Yeah.
That's hilarious.
There's someone sitting on the concrete, but I don't think they're crying.
I just change a little bit, right? But that's the situation of terminology. Now, let's go to application problem. Next page, 486. Example, how about example 5? Yeah. Slightly different situation. Here is a ground, and here is a very big giant tree. Yep. And here is a light, sun. And then the sun make a shadow. Like that, this is the shadow. Am I right?
Angle of depression?
Yeah, down. Yeah, some sense. And then we want to know about what? What's the height of this giant tree? This is a question. And we know from this measurement, this angle is given as a what? 20, what?
20.7.
25.7. Because the experimental result, so it's a little bit here. Okay, what do you need to, what kind of equation can you set up to solve H? You had better, using this real picture, you had better make a what? Simple diagram, yes? What is simple diagram? We can consider tree as a vertical line, yes? And then we are looking for this H, am I right? And then this one means what? Your shadow. What is the shadow?
532.
Yeah, 532. So this is 532, am I right?
Yes.
And this angle is 25.7. How do you figure out H?
Did you use the cosine?
Eh?
You just
When you got
Tangent, right? Tangent. That's right. Why? Because this ratio we need, right? So, here what? We needed to solve. Tangent 25.7 degree is equal to H over 532. Am I right? Of course, this is not the special angle, but anyway we can solve. Cross multiplication. So what? H is equal to what? 532 times what? Tangent 25.7 degree. So using calculator, you can do that. Yes? So if I ask in the exam and then just leave like this, it's fine. Yep. But I don't ask this, of course. Maybe I will give a good number. Yep. Yep.
256.03.
Yeah, something. Okay. And then example 6, very similar to the what? This word definition. I don't want to go. You can try. If you don't understand, next time I can do. Let's go to exercise. Maybe that's better. So page 487. Number, let's see, how about, number 7. You have a triangle like this. Theta and 3, 2. And the question is what? Find all values of trigonometric functions. Exactly we did in the example, right? So what do you need, what do you need to do?
Find the missing side.
That's right. We set up C and find C, right? Yeah. Find C by Pythagorean. So C squared equal to 3 squared plus 2 squared. Am I right?
Yes.
So it needs 13. So C is square root 13. Am I right? Ready? So what is sine theta?
That's two
Um,
over
2 over this.
Sine theta is
opposite of the hypotenuse.
yeah 2 over
Over
square root 13. What is cosine theta?
3 over.
Square root 13. What is tangent theta?
2 over 3.
Yeah, and then everything, the other part you can do, right? Isn't it? So very simple and easy. Now, number 17, find x. Find x, what's the picture? 13. And 60. This is x, right? Oh my God, opposite. Right? Yeah, x is good, 13. How do you find x?
Sine 60. No. Yeah.
What do you want to do? Same thing.
Sine 60.
Sine 60 equal to?
X over 13.
That's right. What is sine 60?
Pi over 2.
Yeah, root 3 over 2. So cross multiplication and then what? 2x equal to 13 square root of 3. So x equal to 13 over 2. Yes? Isn't it? Very good. Easy.
And cos 60 is 1/2.
We don't need to.
No, I'm just wondering.
Co 60 is what?
1/2.
No, you
No,
don't know.
Cosines?
Ah, I see. Yeah, cosine 60, this one itself is, yeah, 1/2.
Oh, okay.
Yes, yes.
Okay.
But I don't ask this, right?
No, I know. I'm just.
Yeah. Yeah, good. So, yeah, because you ask this. How do you find y? For y, you have to solve, right?
Yeah.
Yes, same thing.
Okay.
Very good. Cosine 60 equal to y over 13. So cosine 60 is 1/2, right? So we have 2y equal to 13, so y equal to 13 over 2. Good, very good. How about 18? And then similar, very similar. Is 4, and this is 30. Then, here is x. What do you need to do? 30 is also what? Special angle, yes? Yes, so what?
Tangent.
Very good. tangent 30 equal to what?
4 over x.
Good job. So cross multiplication. Anyway, great. What is tangent 30?
The root of 3 over 2?
Hmm?
The square root of 3 over 2?
Yes, 1 over square root of 3, right? Yes. I mean, the adjacent is longer, right? Same thing, yeah, really good answer. So what? Cross multiplication, and then what do you have? 4 square root of 3 equal to x. That's it? Yep. Is it good? Yeah. See, how much you had better know about the what? Special angle value. If you always wanted to check the, one by one, take too much time. Yes. Now, move to the next page. 488. Yep. How about 31? Evaluate. Sine 30 times cosine 60 plus cosine 30 times sine 60. What is it? Substitute all the what? Special values, right? What is sine 30?
1/2.
1/2. What is cosine 60?
1/2.
Good. Plus what is cosine 30? What is sine 60? Okay, and then what is this? 1/4. Am I right? What is this? This one square, right? So what? Algebra. 3 over 4. Am I right? So this is 1. Yes? Isn't it? Yeah. And 33. Cosine 30 square minus sine 30 square. What is cosine 30?
Root 3 over 2.
Uh-huh. What is sine 30?
1/2.
So what is the first part? We did it before, right before.
Right, so 3
Huh?
over 4.
3 over 4. What is the second part?
1/2.
1/4. So it is what? 1/2. 2/4 is 1/2. Yes? Good. Last one. How about 35? Cosine pi over 4 plus sine pi over 6 square. What do you want to do? What is the cosine pi over 4? 1 over square root of 2. Let's write down this time. Square root of 2 over 2. Plus, what is sine pi over 2?
Square root of 2 over 2.
Me?
Oh, wait.
Yeah, square root 2. Isn't it? No.
Oh, my
I'm
bad.
sorry.
I was
1/2.
thinking of pi over
Yes.
4.
I'm sorry. 1/2. Yes. Square. How do you clean up inside? 2 square root of 2 plus 1 square. Am I right? What is the denominator? 4. Yes? What is your numerator? See, everything is algebra. What is this?
3.
No, don't do that. See, that's what I'm asking. What is this?
The square root.
Compute it. What is it? Square root of 1, square root of 2 plus 1 square is what? Do that. Let me know. What is your answer?
It's the same?
What?
Isn't it? It's not the same.
Not the same.
The square root of 2 squared.
Uh-huh.
It cancels. So 2 plus 1 is 3. 3 over 4?
No, 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 no,
Wait,
no.
I'm sorry.
Go one by one. What is the square root of 2 plus 1 square? Square root of 2 plus 1 times the square root of 2 plus 1. Am I right? Do that. What is your result?
Oh.
You should do that. Always I'm doing and then you don't know.
3 plus 2 times square root 2.
Good. Yes? Yeah. That's your answer. Yes? Very good. Yeah?
Wait, why 3?
You do it like you're factoring. So-
See, I don't want to do this one again and again. See, this is what?
And then you have to,
Oh, okay.
yeah, gotcha.
Thank you.
Am I right? Yes? You should remember. Yes? Yeah, turn by turn. Okay. Another very important question is here. 100% I will ask.
Where's the 3?
47 through 50. 100% in the exam.
Distribute, that was the.
Interesting that the 3 comes from. Where's the 3 come from?
So, you take this and you do your.
I will pick up 48. So here, 48. You have this picture. Let's say this is the A, B, C, D. Let's do that. And what I know, 85, 60, 30.
Okay, plus 1.
And we ask what? This is X. What is X? Yeah, that's the question.
So
Right.
these two, these make a 30, and then it's 2 times the square root
How
of
do you want to solve for X?
when you boil it.
We can,
Here.
we
We have to discuss together. Oh, sorry.
so we can get the hypotenuse outside?
Excuse me?
No.
You have to make a plan. This problem is not by one step. You have to pass it through several steps. What is good way to start? Eh?
Well, we can take the sine of 60 equals 85 over x, and we just call x that hypotenuse there. Yeah. That.
X is here.
Oh, that's
So, what do you want to do?
Probably find all
You
the
can
sides
approach
first.
many different ways. Huh?
I'd find all the sides first. So I would find C to D first.
Okay? So you want to set up this is Y, right?
Yeah.
Okay? And then, Y means what? From here to here. I'm sorry. Okay, what do you want to do next?
Tangent 60.
Very good. Tangent what? Tangent.
Yes.
So set Y, right? And on the triangle ACD, right? Tangent, what?
60.
60 equal to
85 over
85 over Y. What is tangent to 60?
Square root of 3.
Good job. So what is Y? 85 over square root of 3. Am I right?
Yes.
Good.
And then I would do tangent again, but from C
Very
to
good.
D.
On the triangle ABC, right? Tangent
30.
30 equal to
85
over.
y plus x.
Very good. So, and what is tangent to 30?
1/2.
Eh?
No, sorry. 1 over square root of 3.
Yeah, 1 over square root of 3. So cross multiplication, so what? 85 square root of 3 equal to y plus x. Am I right?
Yes.
And you already know y. So x equal to what? 85 square root of 3 minus 85 over square root of 3. Of course it's a weird, but that's the answer. Yes? Can you see? Maybe I will give one more chance. How about 50? This time I don't involve too much. You do. How about 50? Mm. Oops. 5 and 30.
You said 48 through 50 will be on the exam?
Hmm?
You said 48 through 50 will be on the exam?
47 through 50. Similar problem in the exam. Yes. This is your x. Any other information? Yes. And then we know this is, let's say, A, B, C, D. And here this is also yes. How do you want to solve x? How do you want to solve x? From where? What do you want to do? What is your first step?
We know, we can find one of the angles.
Good. Which angle?
C.
Very good. First step is what? What? Good. Yes. So we know this is 60, right? Very good. And then what do you need?
Oh, that's it.
Which triangle do you want to pick up? Which triangle? What do you want to do?
BDC.
Hmm?
BDC.
Good job. What do you want to do?
We can use the sine of 60.
Good.
Five
Sine
over
60 equal to what?
5 over x.
5 over x. Very good. What is sine 60?
One half.
Square root
Oh,
of
3
3
square
over
root of 50.
Square root of 3 over 2. Yes. So what? Square root of 3 x equal to what? 10. Am I right? So x equal to what? 10 over square root of 3. Yes. Am I right? Okay, you can change it, but okay. Oh yeah. So we solve it. Right? Isn't it? We solve it. Very important. Practice more. Now, section 6 is also review because we already learned everything. Yep. So, see, because you pass through the very hard time for chapter 5, now you should feel easy what? Should feel easy for chapter 6 because many things repeated, right? Okay, go to 6.3. We're gonna directly go to the example because we already do everything. Tangent 390. Evaluate. First question. This angle is in which quadrant? This angle is in which quadrant? Yes. So co-terminal angle is what? 30. Am I right? Because one revolution, you go to the 30, right? More. So so we know that T is in first quadrant. Am I right? Yes. Your question is about the tangent. In the first quadrant, your tangent is what? Positive or negative?
Positive.
Positive. So, this one is equal to what? Tangent 30 directly, right? What is it?
1 over root 3.
Yeah. Isn't it? So very easy. See, everything is ready, yeah, to answer. Let's say this is number 1. I'm collecting from the older example from your book.
Which page?
This one is page 493. And another one, let's go. It is from 494. 495. 495. Cotangent, no, let me go. Yeah, sine 240. Exactly, you have to do the same thing. What is your t? T is 240. Am I right? T is in what?
Third quadrant.
Third quadrant, right? Good. So your question is sine. So sine t is positive or negative in third quadrant? Negative. Good. And this is good. See, this one was what? After one revolution, this one is exactly acute angle. Am I right? Because first quadrant, right? So I don't ask something. But this angle is before the one revolution, right? You need what? Reference angle, right? What is your reference angle? Reference angle is around what? 180, right? Or 0. So what is reference angle?
60.
Good. 60. Am I right? Yes. And then this one can be right by what? Because sine is negative. Negative sine 60. Am I right? Yes. What is sine 60?
Root 3 over 2.
Yep. So negative square root 3 over 2. Yes. It's good. This time I don't involve. You have better answer. How about cotangent 495 degrees? What do you need to do first? Anybody can explain? I will follow your explanation. What do you want to do first?
How many rotations past 360?
So it is more than one revolution. Very good. So your t can be divided by what? After the revolution. So 360 plus what? Very good. 135. Very good. So it is the same thing with 135 degree, right? Because the revolution doesn't make any difference, right? After that, what do you want to do? I show everything already. Very good. T is in second quadrant. Good job. And then what you have to ask next? Huh?
Negative?
What do you mean negative?
Cotangent is.
Yeah, cotangent T is in second quadrant is what? Negative, right? Because your x is it's same sign with the tangent, am I right? Good. And this one is greater than 90 degrees. So what? You need the reference angle, am I right?
Yes.
What is reference angle?
Pi over 4.
Good job, 45 degrees. Yes. Isn't it? So, this one, combine this together. So it is what? Negative cotangent 45 degree. Am I right? Yes. Cotangent is what? 1 over tangent. Am I right? So it is negative 1 over tangent. Yeah, 45 degree or pi over 4. Good job. What is tangent to pi over 4?
Root 2 1.
Good. So 1. So it is negative 1 over 1 is negative 1. Yes? It's good? Very good. Yeah. Very good. This one is in page 495, yes. How about one more, two more? Four. Same page. Sine 16 pi over 3. What do you need?
Tilde?
Number of
Hmm?
revolutions.
Oh,
Hmm?
first Personally,
You have to check the revolutions, right?
personally,
So,
I would turn it
whoa.
into degrees.
Yes.
Those are easy to work.
One revolution is 2 pi, yes, but you have a denominator 3. So 2 pi is equivalent to what? What pi over 3? 6 pi over 3. But this is still big. What is 2 revolution?
So
12 pi over 3. What is the 3 revolution? 18 pi over 3, but this is smaller than 18 pi. So
it's
let's
4
do
pi over 3.
2 revolution. You know what I mean? So t is 16 pi over 3 should be what?
4 pi
12 pi
over 3.
over 3 plus what?
4 pi over
4 pi over 3. So it is because it's 2 revolution. So it is 4 pi over 3 same, yes? And then this one is in which quadrant? Yeah, t is in 3rd quadrant. In 3rd quadrant, your sign is what? Yes. And because this one is bigger than 90, so you need a t tilde. What is t tilde?
Pi over 3.
Good job. Yes. So, what did you answer? Negative sine pi over 3. What is sine pi over 3? I asked this kind of
1/2.
problem more than 100 times. Square root 3 over 2.
Yeah, square.
So negative square root 3 over 2. Yes? Yeah. Is it good? Yes.
Technically,
Hmm?
technically,
Hmm.
I can turn the first one into degrees, find it, and then change it back, right?
Change it back to what?
Like I could change the 16 pi into 3 into degrees, figure all of that out, and then turn it back into radians.
You could.
Right. If I-
Yeah. Okay, and then 5. How about this? Secant negative pi over 4. What do you want to do? What do you need to do?
So find out what quadrant it's in.
Yeah, what quadrant? What is your t?
Pi over 4.
Negative pi over 4. T is in which quadrant?
The 4th one.
Right. And in 4th quadrant, your secant t is what?
Negative.
Oh. Secant t is, cosine is in 4th quadrant? Positive. Now, because this is negative pi over 4, do you need a reference angle or not?
No.
Yes. Reference angle is what? Always positive between 0 and pi over 2. Yes? So what is your reference angle? What is your reference angle? Pi over 4. So, summarize it. So this is equal to what? Listen. Just directly secant pi over 4. Am I right? What is secant? Secant is 1 over cosine. So what is cosine pi over 4? 1 over square root 2. So it is what? Flipped multiplication is square root 2. Yes? Yeah. It's good? Nothing. Yeah. Now, your turn. Let me ask exercise problem. Why not?
Oh, this will change your life. It's so helpful.
Let me go more, because you know why I'm hesitating? Because I finished previous class at this moment, but I want to go more because
I'll put the right button so it doesn't have
remember, review. What is the trigonometric identity? What I introduced before, trigonometric identities. What do you remember? Sine what? What is identity? You should remember.
It's a mnemonic.
Huh?
Mnemonic.
What What is identity? What identity do you know?
Opposite over hypotenuse.
This is not the identity. This is the definition. What is the identity? I introduced two identity. Of course, you have had three identity, but I
Sine
give
squared plus
sine square theta or t. Without theta, I don't accept. Somebody write down sine square, cosine square. No. Sine square theta plus
cosine squared
cosine square theta.
equals 1.
Good. How about another identity?
Tan squared
Yes,
theta.
tangent
Yes.
square theta plus 1
1
equal
equals
to
secant squared
secant
theta.
square theta. Am I right?
Yeah.
This is your identity. Memorize it. Now, yeah, you know what? Page 496. Page 496, example 5 is a little bit hard, so that's I'm hesitating, but try, let's try. You have to understand the question. What they ask, I think you did it before. Express sine theta in terms of cosine. So sine need to convert by everything represented by cosine only. Yes? Yep. So starting point is what? How do you rewrite sine as a sum of cosine? What do you need to do? They don't give any assignment. Here, let me ask, because this is nonsense, why I'm here. Let me question. Sine theta convert as a function of cosine theta when theta is in first quadrant. That's my question. What do you want to do? Do you have a question?
No.
So, because theta is first quadrant, your sine should be positive, your cosine should be positive, right? That you have to understand first. In the first quadrant, your sine will be positive and your cosine will be positive. That you have to know first. How, from what you can rewrite sine as only for cosine? From the first identity, right? This one solve for sine, yes, right. From the identity 1, solve for sine theta. Let's go. So isolate. Sine square theta equal to 1 minus cosine square theta. Am I right? And then you like. I know you like it. So square this. Am I right? Yes. And then left hand side is absolute sine theta. Right hand side is what? Just the square root of 1 minus cosine square theta. Am I right? So there are the two chances. Sine theta can be positive or negative, right? Plus minus, right? Front of square root. Yes. But I said first quadrant. So what did you answer? Am I right? Yes? Do you understand? Yeah. See that you have to think something. So how about B? B is also another pattern. What did they say? Express tangent as a sine where theta is in second quadrant. What? Tangent theta convert as a function of sine theta. And theta is in second quadrant. So you have to summarize first. In second quadrant, your tangent is what? Negative. That you have to know. So your answer should be negative, right? Anyway, so to make a connection between tangent and sine, where you have to go? Yeah, which one? Yeah, many different ways you can go. Even not the identity. Starting point is what? we know very well, starting from what? We know tangent theta is what?
Sine theta over.
Sine theta over cosine theta. Am I right?
Yes.
So keep the sine theta. How do you rewrite cosine theta as a sine theta? Oh, opposite with it. I'm so sorry. Opposite. Anyway. So by this part we need to rewrite, right? By the what? Identity 1. Am I right? So what? See here. Solve for what? Cosine theta. Am I right? So what is it? Cosine square theta equal to 1 minus sine square theta. Am I right? Yes? So square root to square root. Yeah? Yeah? And then what? Cosine theta equal to square root to 1 minus sine square theta. Am I right? Now. Here, and the second quadrant. Cosine is positive or negative? Good job. Am I right? So when you choose this cosine, which one is your cosine? Huh? There are two chances plus minus, but we know that cosine theta should be negative in the second quadrant, right? So what? This answer is what?
Minus √1.
That's right. See, that's I told you is not easy if you don't think about clearly. Yes? This is negative. So everything ready. So substitute. So here, your answer is sine theta over negative square root 1 minus sine square theta. That's your answer. Yes? So everything I rewrite by what? Sine theta. Yes? Not that much, but I will gonna ask one question about the what? Function. Yes? Using trigonometry.
You're gonna ask a question like that on the exam?
Yeah, in the one question in the
One.
exam.
Oh, okay.
But not for the final. Final, I will go back to what? Standard easy.
Oh, okay, okay.
But test 2, some problem is what? Harder
Okay.
than standard. Yes? Yeah. But yeah, definitely your final should be easy.
Can you explain that one more time?
With this one,
Yeah, B.
maybe how about the other example is better, right?
No, if that's
Oh,
gonna be on the
which-
exam.
Let's go.
Okay.
Here, this information. So we have to figure out what happened about the sign of each trigonometric function in second quadrant, right?
Mm-hmm.
And the second quadrant, your sine is positive, but cosine is negative, tangent is negative. Am I right?
Mm-hmm.
Yeah. Anyway, we know that tangent can be written by sine over cosine. Yes. But question is what? Tangent converted to the only sine, right?
That's what I don't get. How do you convert it?
Original your book said express tangent theta as only a function of sine theta.
Okay.
So everything divided by sine, right? So cosine needed to convert to the sine. Am I right?
Okay.
Yes.
How do you convert cosine to sine?
Right.
How do you?
Using these two formulas.
Oh, that I did.
Yeah, identity.
Yeah, I
Yes.
did. Okay.
So number one is identity.
Got it.
So from identity, cosine square is 1 minus sine square, right? And then square root of both, and then absolute is this, right?
Okay.
Now, when you decide cosine theta, you have to be careful about this. Yes, cosine should be negative value, right? So plus among the plus minus, you have to choose minus, right?
Mm-hmm.
Yeah, and then substitute.
Oh, because you get the plus minus from squaring both
Yeah,
sides. Oh, okay,
yeah.
okay.
It's good.
Yeah.
Yeah.
And you have to choose the negative because it's negative.
Because second quadrant.
Oh, okay.
Because second quadrant.
Got it.
Okay, how about example 6? Why not? Yeah, I think so. Example 6. Page 497. This type of example 6 or 7, 100% in the exam. Here, tangent theta is 2/3. Theta is in third quadrant. Find cosine. See what is situation? Tangent theta is 2/3 and theta is in what? Third quadrant? And find what? Cosine. how to approach this problem. What do you want to do first? Hmm? What do you want to do first?
Cosine over cosine
Hmm?
equals
Hmm?
2 Sine over cosine equals 2
No. Remember, what's the range of sine? Eh?
Negative 1 to 1?
Range. Negative 1 to 1. Good.
Oh.
Because you did it because homo. What's the range of cosine?
0 to 2 pi?
Eh.
No, wait, negative 2 pi to 2
No. Cosine. Same thing. Negative 1 to 1, right?
Okay.
So, Magnoli, your sine cannot be 2, your cosine cannot be 3. No, don't do that. Okay?
Wait, I have a question.
Yes.
So why was it 0 to 2 pi then? On that
0 to 2
x-axis?
pi is one cycle.
Oh.
One cycle.
1 period.
That's right.
Okay.
Yeah? Okay, go. So what do you want to do first?
I think the 2 and 3 is the sides of a triangle.
Say again?
2 and 3 be the sides of a triangle.
No.
We can use the second formula to replace.
Which one is second
value,
formula?
Like,
Eh.
Do you use the first one?
Eh?
The first one?
Nah. Similar one you did a bit before in chapter 5, I think. Here, starting is this, theta. Third quadrant, yes? Here and third quadrant to what? Your x is what?
Negative.
Negative. Your y is
Negative.
good. And anyway, so your sine is what?
Negative.
Negative. Your cosine is negative. Your tangent is what?
Positive.
Positive. So you got a positive value, right? Yes? Think everything first. Yes? Now we will go. I know you guys are not familiar to this, but you had to better understand that way. This will be helpful, right? And I hope you understand.
Yeah, you would use the second identity.
You wanna use the second identity? Maybe possible. Well, how do you? Because I didn't think about that way. Okay. What do you wanna apply? Second identity? Somebody observe that. So okay. What do you wanna do?
Input 10 equals.
Tangent what? Tangent
Tangent
square theta.
equals 1,
Equal to
1.
Plus 1 equals secant squared.
secant square
Minus
theta
theta minus 1.
minus 1. Now, what do you wanna do?
Solve for.
Substitute. Yes, maybe it's possible. So substitute. So 2/3 square. Why you go this? If I'm you and then you know. Yeah? Huh?
Yeah.
Yeah, and then what? 1 plus 2/3 square equal to secant square theta, right? So, maybe that's okay too.
And then you can turn the secant into cosine, so that would be
Yeah,
1 over
that's what I was
cosine.
Let's go one by one. What is your left hand side? 1 plus 4/9, yes? So what is 1 plus 4/9? 13/9 equal to secant square theta. Am I right?
Yes.
So, cosine square theta is equal to what? Secant square is what? 1 over cosine square. What is it?
1 over cosine.
8? No. From here.
Over 13.
9 over 13, of course. Yes? Am I right?
Yes.
And then what? You like it? What do you like?
It's not the
Square root both, right? Yes? And then, oops, what? Cosine theta equal to, so it is 9 is 3, right? 3 over square root of 13, am I right?
Yes.
Now, here your answer of cosine theta will be what? Negative. So negative 3 over square root of 13. Yes, that's good. Yeah. So I told you, don't need to be one way to go. Yeah. So this is method 1. Method 2. Go back to previous. So what? After this, what we want to do? Draw the picture. Yeah? Yeah? Now, your angle is theta is in third quadrant. Your angle should be what? Oh, I'm sorry. This much. This is your angle. Am I right? And then you can make this kind of triangle. Am I right? This is always 1. Yes? You understand it. Now, yeah, this one. Tangent theta is 2 over 3. Yes? I'm not happy about it. Yes, this method is very bad in that case. Why I'm hesitating? Because this is theta, yeah? So this is what? Theta, yeah. This is theta tilde, am I right? Yeah? And I see why Magliolis talk about. This is 1, am I right? So we have to know about this x and this y, yes? This angle is not a special angle, so what? Not easy. Only I know what? Here, if I really want to go method 2, and then what? This one is my x, am I right? This one is my y, yes? Yeah? So here, what from this triangle, what we can say? Tangent theta equal to what? Y over x, right? But I don't know y, I don't know x. But tangent theta is what? 2 over 3, yes? See? And then, this is bad. Second method is not good, but we can try. As an optional, I will talk about. So here, solve this. What do you have? You can get a relation between x and y. So what? The 3y equal to 2x. Am I right? So y equal to 2/3 x. Am I right? You understand? So this triangle y can divide by what? 2/3 x. Am I right? And then apply what? Pythagorean. Yep. Yes? Yeah, I don't like this method. Yes. Pythagorean and then what? X squared plus 2/3 x squared equal to 1. Am I right? Very bad. I know. Already bad. So, compute this. X squared plus what? 4x squared over 9 equal to 1. Am I right? So here what? This one plus this one is what? 13 over 9x squared equal to 1. Am I right? So here x squared equal to 9 over 13. Now again, square root, right? Yes. And then in here, your x should be what? Positive or negative? Because third quadrant, right? So negative 3 over square root 13. We don't like this method. This is much easier, yes? Very good. And we got this. And then what is your y? Y is, yeah, 2/3 times what? X. Negative 3 over square root 13. So y is what? Negative 2 over square root 13. Am I right? Yeah, and then now, because I know this length, and then you can figure out what? Cosine, yes? Not good.
But
So
this
there-
way is way longer, right?
Yes.
Okay.
Why this kind of thing happen? Because your angle is, your tangent doesn't make any kind of direct value of x and y, yes? Yeah, good to check first, and then you choose a better way. Isn't it? Yeah. Good. Very good. How about the example 7? And then maybe almost we stop. Example 7. Here, what is given? Secant theta is 2. Theta is in fourth quadrant. Now what I ask? Find all 5. Find all values of the trigonometric function. What do you want to do? Oops. What do you want to do?
Is it cosine that equals 1/2?
Right, exactly. So we already got 1. So here, cosine theta equal to 1/2, and the secant theta equal to 2. We have to find another form, right?
Quadrant 4. You can use the second identity to find tan.
So second identity, okay? So what?
So secant
What?
is 4.
1 plus tangent
Yeah.
square theta equal to 1/2 square. Am I right? But before that, I already always starting with what? What's the property at the fourth quadrant? Yes. In fourth quadrant, your x is positive, y is negative. Am I right?
Yes.
And your sine is negative, cosine is positive, your tangent is negative. Am I right? Let's go. So anyway, so solve for tangent square.
Excuse me.
And then,
Why is it one
Eh?
half instead of 2?
say again?
Why is it 1/2 instead of
Oh, sorry, my mistake. Am I right? So what? It is 3, yes? So, square root both, and then, in this case, your tangent should be positive or negative? Yeah, negative square root 3. Am I right? Yeah, and then from here, you know that what is cotangent theta? Negative 1 over square root 3. So now what do you need to do?
Sine.
Sine. So how do you figure out sine? Yeah.
Tangent equals sine over cosine.
Excuse me?
Tan equals sine over cosine.
Okay, so from here, what? Tangent is sine theta over cosine theta equal to negative square root 3. Am I right? And then what? You know cosine theta is what?
1/2.
Yeah. Am I right? So what? Sine theta is equal to what? Negative square root 3 over 2. Yes? So what is cosecant theta? Negative 2 over square root 3. Yes? Stop here. Yes? Is it good? Yeah. And you can use the method too. Yeah? Yeah. Sometimes, this case, I think method 2 is good too. Method 2 is overload.
So they're both good, it just depends on the situation.
Yeah, which one is better? You have to choose.
Okay.
Mhm. Yeah. Last one. How do you measure the arbitrary triangle?
What?
You know, here, area, sorry. Let's, this is B, this is H. And then, what is the area? How do you measure the area?
Is that the base times height divided by 2?
That's right. 1/2 E times H. Am I right? How about this shape? This is B, this is H. How do you measure the area? How do you measure the area? This is triangle, yes.
Oh, I remember. Actually, I don't. I thought I knew. Okay, so Wait, isn't it, we measure the right angle inside the triangle already?
I don't put the angle yet.
Okay, never mind.
Huh?
We're not using
have
the
to find
Pythagorean
the-
theorem? Are we not using the Pythagorean theorem?
You have to find the height, right?
I give height, h.
What?
The height is h.
I know that.
There's no numbers?
Yeah, there's no numbers.
Here is the geometry. Here, why we did this? Think about this. I flip this one to here. Yeah? And then what? What's the area of this? What's the area of this? It's a rectangular.
Two sides.
B times h. And this one is exactly the same. So what? The triangle is what? 1/2 b times h. Yes?
Yes.
Here I'm doing. This one flip here. Yes? Yep. This one flip here. What's the area of this? What's the area of this?
B
Base times
times
Base times height,
What?
Base and height.
base times height, b times h.
Good. And what's the area of this? This is half of this.
Half
Yes?
of that.
So what?
Half of b times h.
Yeah.
Mm-hmm.
Am I right?
One half bh.
This one you did in high school, right? Okay, now.
Probably no.
What we have to learn, what we have to learn in pre-calc. Now.
Okay.
If we know this angle is theta,
Uh-huh.
yep, and then from my question is, rewrite h using theta. How do you rewrite h using theta triangle?
B times sine c.
What?
I don't know.
Almost. Yeah. Okay, I have to know something else. So
Okay.
this is B, yes, I have to go further. Let's say this is A, let's say this is B. So this is A, oh my God.
No.
Let's see. So this is, oh no, it's very bad. Sorry. It's okay because the same thing. So this is A, B, and then this should be B. This is A, and then this is A, this is C. Okay? Let's go. Yes? Because my previous one is weird. Okay? So I know what? 3 lengths are ABC. Am I right? And one of the angle is theta. How do you measure H? Oh, this is D, of course. From trigonometry, how do you measure H? Using sine or cosine or tangent?
Sine,
Sine.
What?
sine, theta, whatever you call it.
Sine theta equal to what? Eh?
H over A.
Very good, H over A. ABC is given, yes? So what? Here, H is what? A sine theta. Am I right? And then we substitute here. What is your new formula? 1/2 B times A sine theta is way to measure your area in general. Yes? This is a trigonometry. Yes? Do you understand?
How does that include that second smaller triangle if you don't have the smaller, the
Smaller
second
triangle?
B?
What say again? Here, this is not right angle. Unfortunately, this is arbitrary angle. I only know one angle is theta. Yes?
Yes, so wouldn't that only be the angle of the,
No, not necessary. Okay, we have time.
BC?
Okay, how about this example? Here, example. Here. Next page 498. Example 8. You have this triangle. Can be any type of triangle. So you have this. And you know this is 120. And you know this is 10 centimeter. and this is 3 centimeter. And then find the area. So not necessary to know about everything. So let's say this is what? A, B, C. Area.
Is it 15?
Huh?
Is it 15?
15?
Well, I mean, base times height?
No.
No?
Do you know height? This is 120 degree, not the right angle. What do you need? You have to find the what? Height first, right? Do you understand? Height first. How do you make a height? Height will be, because the angle is here, right? You cannot break down like this, isn't it? That's not a good idea. You understand what I mean? So my height wants to be what? Like this. Let's say this is D. Am I right? Am I right? And then, how can I use the sine, cosine, tangent in which triangle? In triangle what?
Triangle BCD.
Good. What do you need to know?
You know, angle B is
Very good. See, very good. Angle B is what?
63.
Good job. 60. Am I right? Now, so this is your H. I'm sorry. Yes? Okay, so what? And what? In here, we can measure H, isn't it? What is your H?
It's
H is what? No. What is the relation? Ian, I'm sorry.
3h squared plus.
No, don't go too much that way.
Mm-hmm.
I told you, you have to use the what? You did before, right before. Sine, very good. Sine 60 equal to what?
H over
Very good. H over what?
3.
Good job.
Why?
What is sine 60?
But why is it sine?
Just a minute. Sine 60, what is sine 60?
Root 3 over.
Yep. So what? The 2h equal to 3 square root of 3. So what? H is what? 3 square root of 3 over 2. Am I right? What is your question?
Why is it sine 60? If it's
Well,
120
here.
degrees.
Here, this one is 60.
Oh, that part. Oh,
Yeah.
okay.
It's good?
For sure.
So we got H. Why we got H? Go back to here. So this H is what? 3 square root of 3 over 2. Am I right? Yep. And what is your base? What is your base? 10. So what is your area?
1/2.
1/2.
10 times.
10 times.
3.
And that's your area. Yes? Centimeter square. Yes? Isn't it? Somebody maybe can answer. Oh, this one should be base? No. Angle is like more than here because you see, think about it. Your H can be also here. Am I right? Do you understand? Yep. H can move to here. Yes?
So you're
Isn't
just
it?
choosing the angle you want to look at?
Here, geometry. Let me go back to geometry.
I've never taken geometry.
Here, your high school teach. See, this is H. And then now, you see what I want to do? Here. Here, yes. And here, what can you do? This part is what? See here. How about that way? Yeah, how about? See here, this one, and I'm looking for this area is what? 10 multiply H. Am I right? And now, here, and this is very bad to I explain. I don't want to explain that way. See, you have to break down. How can this area is equal to this area? Just a minute. Okay, what about this way? Sorry. So like this. So here, this area, I'm sorry. This area is equal to, see, my chalk. This area is equal to this area. Am I right? Yes?
Yes.
Why? Because this area moved to this area. Am I right? You understand? Yes?
I don't understand. How does it move?
You know what? Usually if I want to teach in the elementary school, maybe I will gonna use the paper and scissors. Cut, and make it. What they mean the n plus h is.
That would be fun. We should do that.
Do by yourself at home. Think about it. So anyway, what is a good idea? Here. Original picture is this. Original picture is this, right? And I measure h here. Am I right? By this, yes. And we are looking for this green area, right? Now what I want to do, I move this one to here. Let me. What is better way to go? See, I'm thinking. So move to here. And then a little bit here. This is still h, right? And this. Let me see. Here, because you cannot see really easily, clearly. Let me explain what is better way to explain. No, not this. Yeah, how about this way? So, I flipped this one here. And then this is the parallelogram. Am I right? What is the way to measure the parallelogram? Right. Base 10. So this is base 10. Am I right? Base times height, isn't it? So this one is what? Base 10 times h, right? Yeah, maybe that's the best way to explain. To measure this area is what? 1/2. Yes? Yeah, that's it. Maybe that's the best way to explain. Yes? Yeah, because this one is parallelogram. Am I right? Good. So what I want to emphasize, this is your base, not this is your base. Yes? That's what I want to emphasize. Yes? Okay? If you have a time, and then try some more exercise. 47. That's yeah. Try. 47, 54, 63, 64. One problem, almost the same thing in the exam. Let me do again. 47, 54, 63, 64. One problem is very similar to your test problem. Yes?
So what was 47? 47, 53, 64.
47, 54, 63, 64. Let me go to roll call.
On what page? Oh,
Yeah.
that page? 498.
499. No Julian. Marshall here. And Bagroli here. And Kristen here. And you are Taylor, right?
Yes.
Gabriel, no. Today, attendance 4. Zachary here. No Anna. Rachel here. Chelsea, no. Felix here. David, no. And